Hello everyone and welcome to another video in FA25. So in this video we are going to discuss a concept called control flow, and to introduce, we'll introduce this concept with an example. So far in this class what we've done is we have stuff where we have code written on a particular line and then everything gets evaluated when it is run. Okay, so we can control the flow about what is actually executed with particular operations, if else and if else, which if else is not the same thing as if combined with an else. We'll get into it a little bit later. So for instance, an if statement would be some condition, or here's the syntax, and we have curly brace and say we want a particular number to display. So what's going to happen is if condition is satisfied, then code is executed. Now you could, with one particular line, you don't need the brackets necessarily. And I should actually separate here, because if is not actually a function, it's something that is this keyword for this statement that is going to run and provide this conditional execution. Okay, but I use the brackets just to keep in mind that I'm going to run some expression that is only triggered if a condition is satisfied. So here condition isn't even triggered because condition, of course, is some name that isn't assigned in the global environment. So instead I had condition, spelling is difficult. Condition equals false, for instance. So I'm taking the logical value false, assign the name condition, and we can see what happens. If we try if condition, nothing happens. 42 does not get returned in the global environment. Our flow is broken up because we controlled it with this if statement, with this condition that was false that didn't actually run. Okay, so if I change it to 2, we get something here. So this is actually, of course, very simple syntax, very simple example. We'll get into more difficult realistic cases in the lab video. But this demonstrates this how we can control the flow using these conditional execution statements like if. Okay, so I could do something like here, where if, so let's walk through it before we run. Okay, so what's going to happen? So I have condition, which I am changing in the global environment to be false. So we already saw where if we run this on something that is false, what's inside the curly braces, the expressions, does not get evaluated. So now this else catches what's happening, catches the other case to return, to run an expression when this is not satisfied. So condition equals false. So let's break it out. We get nothing here, right? Didn't run, didn't return 42. Now if I run the whole block, we get negative 42. So condition failed, else caught it. You could do something like if not condition, and that would do, and that would also catch it, but this is a little bit tighter. And as you can see, less room for error. Okay, great. All right, so then we can chain these. So let's say I get slightly more interesting here, and I have x, which we will say is 0. If x greater than 0, run something. What's 42? Let's have y equals 0. Okay, and now I can do stuff like, actually, you know what? I'm going to do else if x greater than 10, then y equals 21, else if x greater than 0, y equals 1, and then else, let's do y equals negative 42. Okay. So I have x, it's 0, it's y, or y is 0. Okay, so let's walk through it. So x is greater than 20. And keeping in mind that it's not doing x greater than 20, it's the object given the name x is greater than 20, but we can't say that every single time. Okay, so is x greater than 20? No, so that isn't going to get executed. And then else, if, so I'm doing some case splitting here, x greater than 10, no it is not. Is x greater than 0? No. So I have a catch-all at the end, so y should be negative 42. I'm just going to do that. And that's what happens. You can see it in the global environment. Nothing is returned in the console because I have an assignment inside of the expressions, but you can see it change in the global environment. So now, what happens if I do x equals 30? Well, I should get y equals 42 when I run it. And I do, okay, great, because x is greater than 30, and then all of the other conditions aren't satisfied. So now it's getting in between case. X is 15. So what's going to happen? So let's walk through it again. Okay, so x greater than 20? No. X greater than 10? Yes. So then y should be 21. X greater than 0? Coming down the chain? Yes. 15 is greater than 0. So so far in this class, what we've seen is that if you have successive assigning of the same name to different objects, then whatever is run latest will be what is assigned. However, in this case, this sort of flow short circuits at the first condition at which something is satisfied. So let's see it. So by this construction of these nested if, else statements, whichever one is first to satisfy is the thing that gets run. That's what I hypothesize. So it should be y equals 21. And in fact it is. Okay, good. Okay, great. So you can see how this kind of how this operates. Now, granted, these are pretty simple examples, but we'll do something more compelling in the lab. And I should emphasize here. So if else, very important for control flow. And then later in another much longer video, we'll cover different loops, different iteration through things, for, while, repeat. And I could have combined these into one longer, more appropriately length videos, I guess, but I want to disentangle this conditional execution, if else, which is very foundational in R, from these types of loops, which, while possibly things that you've seen before in other programming classes, are not that widely used or useful in R, because of R's ability to vectorize and work with apply statements, which can be applied to a vector directly, which we haven't seen yet, but we'll get into. So these types of for loops, while loops, repeat, are things that we don't need to use too often, and we'll get into it, of course, and when they are useful and when not to use them in the next video. But anyway, so normally this kind of control flow would lump these two things together. However, if else are things that are still widely used in R, while more traditional concepts of for loop, while loop, repeat loop are not. Okay, so now what the heck is this if else statement? Okay, so let's generate some numbers as I have done before in this class. Oops, not univ. 20. And we'll just round for usability. So I get some numbers. Okay. And you may have seen, if you've read the notes, that I could do this, call some common value 385. And what this does is it sets the random seed so that every time I run this code in succession, I I get the same exact values. This is good for reproducibility, but okay, so don't need it now because I'm just doing demonstrations. Okay, so Z. Okay, so what I can do is check whether or not a condition is satisfied. So keep in mind, I have 20 values in this vector Z. They're generated from a uniform distribution. There's some rounding. And so this is going to check these values element-wise by length coercion. Okay, so then I have two more arguments I need to specify. What happens when the condition is satisfied, and what happens when it is not satisfied. Okay, so I have Z, and we can see that some are satisfied, some aren't. So for instance, for the first element, I should get yes, second yes, third no. Okay, and that's what I get. So it's going element-wise, and it's doing different things based on whether or not the condition is satisfied. Okay, so now this is pretty nifty. Okay, so if I have 20 elements. Okay, so let's run it and see what happens. So I get character 1, character 2, bunch of no's, character 12, 15, 17, okay, so forth. So what's going on here? There's a lot of moving parts. So it's going, so this thing is the same length, 20, right? All the integer vectors, all the integers ranging from 1 to 20 in increasing order. So when the condition is satisfied, it's going to return the corresponding element of this vector. And when it isn't, it's going to return no. Remember that no is a atomic logical vector of length 1 that's getting length coerced to the thing under study so that it is length 20. Okay, so the first element is in fact, the first element is Z is greater than 0.6, greater than or equal to 0.6. So is the second. So it's returning 1, 2. The third one is not. And then it goes all the way through until we get to the 12th one, which is greater than 0.6, greater than or equal to 0.6. And we can get the number 12. It's the 12th index of this vector here. Okay, so then when it's going through and completing this task, we have type coercion going on. Character, I guess, is higher in the hierarchy of types, so that the whole thing gets coerced to type character. So I contend that if you understand what is going on with this statement right here, then you understand a lot about R up until this point. So this is something to play around with. For just one more thing, what happens if we, well, okay, first of all, let's do something a little bit more. Let's get rid of some of this coercion because it's confusing. But let's leave it. Let's leave that if-else statement to play around with. Okay. So now the elements of Z, which are not greater than or equal to 0.6, would be -1. We have none of this type coercion going on with character elements, and we can see it here. Okay. So now, let's say I change this to 19. Okay, so then let's do something a little bit more interesting. Okay, if I do this, so now Z is less than 0.6, then I conjecture that since this thing is 19, that the first element will get recycled, and that this should turn into a 1. And it does. Okay, so it's a little bit concerning that I have a vector of length 20. Oh, actually, before I do that, I can just change it. These are the same thing. Okay. It's a little bit concerning that I have a vector of length 20 and a vector of length 19. They're not multiples of each other. Normally R complains of that sort of thing. and it just does this automatic recycling without prompting us for a warning. So that's a little bit concerning. However, I've worked with if else a whole bunch. If you're just being careful with it, you don't have this kind of recycling problem coming up. I shouldn't say I haven't seen it. I haven't detected it as a problem in anything that I've done while being careful. So, but something to keep in mind that it does recycle. Okay, so what we have here, just wrapping it all up, we have covered, or we're covering a broader topic, control flow, where now things aren't just running in always getting evaluated in sequence. We have some conditions or some cases in which things are not getting evaluated based on whether or not they satisfy a condition, namely these if statements, if else, and then of course else if, and where we can do this kind of further case splitting. And then this if else statement here, which looks at a logical vector. And if the corresponding element is true, something happens. And if the corresponding element is false, something else happens. So if true, then do this, else do this. Okay. All right, so this is a relatively short video. And then we'll get into loops in a longer video next. So if you made it to the end, thank you. Good job. All right, I will see you soon. Take care. Bye.